All right, so the compound interest formula that we were looking at the last day is very useful and it is a time saver. But I mentioned during that video, it has its limitations, okay? So if you are saving or investing money or depositing money, you can only use the compound interest formula if you don't withdraw money during the period, you don't add any more money into the account during the period, or the interest rate doesn't change. Okay, so you have to just put money in the account and leave it there for whatever period, and then the compound interest formula will tell you how much it's worth at the end of that period. Okay, if those conditions are met, it's definitely way quicker than doing it year by year. Okay, so I had an example here in the last video where it was 8 years. So if I had to do that year by year by year, add on the interest, calculate the interest next year, etc., keep doing that, it would take me a long time. The formula is way quicker. Okay, but as I said, if you're withdrawing money, adding more money in, or the interest rate is changing, then you have to do it year by year. Okay, the same is the case with loans. Okay, so we can only use that compound interest formula if you borrow money and then you do not repay any money until the very end of the loan. All right, and also the interest rate stays the same for the full period of the loan. All right, now that does happen sometimes with loans, but I would say definitely the more common thing to happen in real life with loans is you are repaying it during the period. Okay, so let's say an example like this from the book. Maeve gets a loan of €9,000 to buy a car. The interest rate available for the loan is 10.9%, APR, so it's an annual rate. She has arranged to pay back the loan as follows. So 2,000 at the end of year 1, 2,000 at the end of year 2, the remainder at the end of the third year. So the fact that she is repaying money during the loan means I cannot use the compound interest formula here, and I will have to look at this question year by year. All right, so that's what I will do now. So I will look at year 1, and we're just going to say at the end of year 1, before she repays this money, it's €9,000 that she's borrowed. Her interest rate is 10.9%. So if we get 10.9%, so 0.109, that's €981. So she has borrowed 9,000 at 10.9%. So it is €981 interest that she will have to pay the bank. So plus 9,000. So that's at the end of year 1, she owes €9,981. But what happens? She then pays off 2,000. So it is now 7,981 that she owes. Okay, so you do the interest before the repayment. All right, so at the end of year 1, she owes 7,981. So that means year 2 then, it is 7,981 that she owes. Interest rate is not changing, it is still 10.9%. So 7,981 multiplied by 10.9% is 869.93. So this is money, so I'll go to 2 decimal places. So 869.93. Add that on to the 7,981. And that is 8,850.93. So don't forget, even though it's a loan, the interest is getting added on. The bank is charging you interest. You have to pay that back on top of what they're paying you. So it is 8,850.93 she owes at the end of year 2. What happens then? She repays another 2,000. So it is now 6,850.93. In year 3 then, so it's at the end of this year that she repays the rest of it, but we still have to calculate another year's interest in year 3. So it's the 6,850.93 from the end of year 2. she's going to pay interest of 10.9%, so 6,850.93 multiplied by 0.109, that is 746. To 2 decimal places, 75. So that's the interest the bank charges her, so she has to repay that on top of the 6,850.93. So that is 7,597.68. So what amount will she have to pay at the end of the third year? That's the number they're looking for. Okay, so 7,597.68. So just be careful with a question like this. What they're actually asking you for. Could be total repayments, it could be the total amount of interest she has to pay. In this case it is, what's that payment at the end of year 3 to pay off the loan in full? So it is 7,597. And again, the reason I couldn't use the formula there is because of the repayments. Okay, so if you're repaying money or you're borrowing extra money, or if the interest rate changed, if any of that happens, you cannot use that compound interest formula from the log tables. Okay, so the same would be the case in a deposit question, okay, in a savings or investment question, where I was, as I said before, withdrawing money, depositing more money in, or if the interest rate changes. All right. You can get questions like this where you might be comparing this method of repaying it to leaving it all to the end and repaying it all at the end, and there might be a different interest rate if you do it that way, and it might just ask you to compare which is better. So in that case, you'd be looking at how much interest does the person pay under both conditions, and whichever one is more interest, that's more expensive, so go with the other option if you can. All right, so that's that example. I'm just going to do one here where there's not a similar example in the book. So let's say, so this is looking at something slightly different. So let's say you deposit €9,000 in a bank for 4 years, and at the end of that period, it is worth €10,129.58. You did not withdraw or deposit any money during the 4 years. What interest rate did the bank use? So this is different because I am solving for an interest rate. All right, so, but let's just look at the example. You deposit 9,000 for 4 years. At the end of that period, it's worth that. And it's what interest rate did the bank use? So there's no mention of withdrawing money, depositing extra money, the interest rate changing. So it looks to me like I can use the compound interest formula here. Okay, so I will do that, and then we'll kind of look at what we're actually been asked in the question. So I think I can use the formula here. So final amount is equal to principal on 1 plus I to the power of t. So what do I know in this question? So this question is different because I know this final amount. This is what I'm usually trying to figure out. So I've got 10,129.58 is equal to the principal. So what I deposited at the start is 9,000 on 1 plus what interest rate did the bank use? So this is what I don't know, and I'm told it's for 4 years. So it's a typical thing that we get in maths. We know how to use the formula, so now they're going to change it up, and we know the answer, and we're looking for something else in the formula. So we're using it to solve for something. I've only one unknown, so I'm able to solve this. So right hand side there is 1 plus I to the power of 4 multiplied by 9,000. So this 9,000 is multiplied by 9,000. So my first step is going to be bring that over, and it will be divided by 9,000. All right, so I'm bringing the 9,000 over. So I get 10,129.58 divided by 9,000 is equal to 1 plus I to the power of 4. Okay, you could leave this as a fraction if you want, or you can figure it out. It doesn't really matter. You're probably better off leaving it as a fraction, because then you won't have to worry about rounding it off. Okay, so you could go 10129.58 divided by 9,000, get that, and then round it off to I would say a few decimal places here, just so you don't throw your final answer off. But I'm actually just going to leave it as a fraction, because then I don't have to worry about rounding, and I don't have to worry about my answer being thrown off a little bit if I round too much. So I'm going to leave it there. Now, 1 plus I to the power of 4 is equal to this, and I'm trying to solve for I. So my problem here is this power of 4. So the entire right-hand side here is to the power of 4. Now, this is something you probably haven't seen too often, possibly not at all before. But let's say, just for a second, let's say if you know x squared is equal to 9. How do you solve for x? You get the square root of both sides. So the square root of x squared is just x, and the square root of 9 is 3. Okay, so to solve an x squared, you use square root. So here, we're just going to do the same thing, okay? But instead of square root, we're going to get what's called the fourth root. So the fourth root of 1 plus I to the power of 4. And just like up here, when square root of x squared kind of cancelled and you were just left with x, here, it's going to just leave me with the 1 plus I. So to get rid of a power of 4 like this, when you're trying to solve for something, you use the fourth root, okay? If I get the fourth root of the right-hand side, you have to do the same thing to the left-hand side. So 1012958 divided by 9,000. All right. So the fourth root is just like, so what does x squared mean? What does the square root mean? It's what number multiplied by itself gives you that. The fourth root is what number kind of multiplied by itself 4 times. So you're kind of undoing that. Okay, so what number multiplied by itself 4 times gives you this. Okay, you don't need to worry too much about it. You just need to know you're doing the same thing to both sides to get rid of this, and it's going to ultimately give us our answer. All right, so finishing this off up here then. As I said, on the right-hand side, the fourth root of 1 plus I to the power of 4, the reason we do this is because it leaves us with 1 plus I. So the power of 4 and the fourth root cancel each other out. On the left-hand side then, I can figure this out on my calculator. So it is, you see here on your calculator, you've got a y to the power of x. So that's how you raise anything to the power of any power. Above that, you've got an x and then the root symbol. So that's how you do any power. So this one here is just the square root. You see above that second function, you've got cube root. Above this y to the x, I've basically got any root. So you put in what root you're looking for. I'm looking for the fourth root here. So 4 second function y to the x. And you see it's getting me the fourth root of this. So then it's just 1012958 over 9,000. That equals 1.03 and then a whole load of zeros. So I'm happy enough just to round that off to 1.03. So over here then 1.03 is equal to 1 plus I. So take away 1 from both sides and you'll get 0.03 is I. So that's my interest rate as a decimal. So what's my interest rate? 3%. All right. So that's how you use this formula to solve for an interest rate. Okay, so you can get different years, a different number of years here. So if it was 5 years, it'd be the fifth root. If it was 6 years, it'd be the sixth root, whatever. But it's the same method you'll be using. All right. And again, the reason I was able to use the formula there is because I was putting 9,000 away for 4 years. There was no mention of withdrawals or adding more money or the interest rate changing. All right, I'm just going to do the next example in your book and then that's it for this video. So this one here, Emily would like to invest €10,000 for 2 years. A bank is offering a rate of 2% for the first year and a higher rate for the second year. So already I can't use the formula. Okay, so 2% for the first year and then a higher rate for the second year. So if the interest rate is changing, you can't use the compound interest formula. So I'm going to have to do this one year by year. But seeing as it's only 2 years, that's not going to be, it's not going to take me too long. So a higher rate for the second year if the money is retained in the account. Just something else new here. So tax of 35% will be deducted from the interest earned. So you are going to be paid interest on what you save, but then you have to pay some tax on that. So you're not going to get all your interest. Tax is going to be taken away from some of it. So part one here, how much will the investment be worth at the end of 1 year after tax has been deducted? Okay, so part one. So year one, so you invest €10,000. The interest rate is 2%. So 10,000 multiplied by 2% is €200. So normally what we would say is 10,000 plus 200, I've got €10,200 now. But what happens? Tax of 35% will be deducted from the interest earned. So you need to subtract 35% away from this. Okay, so €200 multiplied by 35% is 70. So instead of receiving €200 interest, you receive 200 take away 70 tax. You only actually earn €130, or you only see €130 of that interest. Okay, they don't say it here, but that's called deposit interest retention tax. So deposit interest retention tax, so DIRT for short. Okay, so you might have heard that in business studies, or you might know it from somewhere else. Okay, so that's what DIRT is. So you earn interest, but then they take tax away from it. So you only actually see the after-tax interest. All right, so what's the question actually asking here? How much is the investment worth at the end of 1 year? So you put 10,000 away, you actually get €130 interest. So 10,000 plus 130 is 10,130 at end of year one. All right, so that's that part done. Now, part two, Emily calculates that after tax has been deducted, her investment will be worth $10,294.61 at the end of the second year. Calculate the rate of interest for the second year. All right, so in the second year, it's a little bit different. I know what it's worth at the end. It's the actual interest rate I'm trying to figure out here. All right, so this will be a little bit trickier. So first thing I'm going to figure out is at the end of year one, which is also the start of year two, I've got 10,130. At the end of year two, I've got this much. So let's subtract those away from each other. And that'll tell me how much interest I received in year two. So you've got your 10,294.61 at the end. Take away the 10,130. So 10,294.61. Take away 10,130. And that is 164.61. Okay, so that's how much the investment grew during 2 years. Okay, but what do we know about what happened during the second year? We know that tax is still being deducted. So this isn't the actual interest. So if you look at at year one, this figure here is not the 200. This figure here is the 130. It's the after-tax interest. So that's what was actually added on to your investment. That must be after the 35% tax has been deducted. All right. So that means the 164.61, if it is after 35% has been deducted, it must be equal to 65% of interest. Okay, so if 35% is taken away from something, 65% of it is left. So what I need to figure out to get the interest rate is kind of this €200 number. I need to get the 100% to figure out the interest rate. This is only the 65%. So if 164.61 is equal to 65%, the best way I think of getting to 100% is first figure out what's 1% equal to, and then figure out what 100% is equal to. So if 164.61 is equal to 65%, well then 164.61 divided by 65 is equal to 1%. So you divide both sides by 65. So 164.61 is 1%. And then to get back up to 100%, you multiply this 164.61 over 65. So this is my 1%, and I multiply that by 100. And that gets me back to 100% of interest, and that's what I need to figure out the actual interest rate. So 164.61 divided by 65 to figure out what's 1% equal to, and then multiply by 100 to get what's 100% equal to. And it is 253. This is money, but I'm just going to go to a couple of extra per decimal points just in case it makes a difference to the answer. So I'll go 246.2, say, is equal to 100%. All right. Or if you went, look, if you round it off, it's going to, so that's it, we'll round it off because people will probably do that. So 253.25 is the 100%. All right. So €253.25 is the actual interest you earned before tax was taken away. So 253 is the interest that you earned on 10,130. All right. So if you put 253.25 over 10,130, that's your interest rate. Okay. If I lay that out, maybe what would have happened in year 2? You started with 10,130. It's multiplied by some interest rate, and then it's equal to 253.25. So to actually figure out that interest rate, I multiply by this, so bring it over, and it's divided by, so I is equal to 253.25 over 10,130. So 253.25 divided by 10,130, and I get 1 over 40, so an interest rate of 0.025. What does the question actually ask me for? So calculate the rate of interest in the second year. So it's 0.025. If you multiply that by 100, it's 2.5%. Okay, so the interest rate is 2.5% in the second year. All right, so there's a lot of moving parts in that second one. Okay, it is a little bit tricky. I think the first part should be all right, just once you know how dirt works. The second part, there's a lot of kind of algebra there where you could go wrong, but just have a look at that maybe a couple of times before trying the questions in the book. All right, so they are 2 of the examples from the book that I've done, so you can look at those fully done out as well. And there's the third example as well, or the middle example that I did. All right,